Hello dear students. So today we'll discuss our next part of this memory management, and our today's topic is dynamic loading. When a process is executed, the entire program is loaded into physical memory. Size of the physical memory is limited. As you know, presently we are using uh, the standard laptop or desktop having 2 GB or max to max 4 GB of memory. So this memory size is limited, and this limitation actually doesn't provide better memory utilization. So that's why you used the concept dynamic loading. A program, or sometimes it is also called routine, has several parts. Main program having different subprograms. The subprograms may have other subprograms. With dynamic loading concept, routine or subprogram is not loaded until it is called. All routine are kept into disk. So first of all, main program is loaded into main memory and it is executed. Then main program or routine will call subroutines. Now we'll focus on what are the different advantages which is provided by dynamic loading concept. First advantage is unused program or routine will never loaded. And second point is practically it is useful when we are dealing with large program, but there is a constraints that actually depends on the how the programmer will design his or her code. Means what? If we write multi-threaded program, then we obtain this dynamic loading concept. But if we rather write an entire program in a single main file, then we cannot achieve this dynamic loading. It will become static loading concept. So dynamic loading enhance the performance compared to static loading. Now I will come to our next interesting point, that is overlays concept. Overlays concept, it is very much useful because this concept is useful when free memory space is less than our required memory space. Means what? Say our system having a free memory 100 KB, but our required memory to execute any program is 120 KB, which is quite larger. Then how we can solve this type of problem? So when we are playing a high end graphics video game that actually requires much larger or higher memory space to support this and this high quality graphics. So to deal this type of problem, we use overlays concept. I give a simple example of overlays, how we deal such type of problem by using overlays, by using two-pass assembler. Suppose to load everything once, we would require 200 KB of memory space. But if only 150 of memory space is available, then how can we execute that process? Means our requesting memory is 200 KB, but our existing memory space is 150 KB. Then how we can solve this type of problem? We can solve this type of problem by using two-pass assembler, where actually the entire program, we subdivide the main program into two subparts, function 1 and function 2. Rather than it is called pass 1 and pass 2. The size of the pass 1 is say 70 KB and size of the pass 2 is say 80 KB. And another important part, that is called symbol table, a symbolic table, which I in my last video lecture I detail discuss. When we write any source program, By default, the source program is represented through symbolic address, and the detailed information of symbolic address is stored in symbolic table. And another important part is common routine. When we write any C program, we just add the header file in the top portion, like hash include stdio.h, hash include conio.h, and these other header files. Or when we write any object oriented program, we import some packages. All these things are necessarily required to execute the entire program. So this header part is actually common routine or common part of any program. So look at this diagram. Pass 1, the size of the pass 1 is 70 KB and pass 2 is 80 KB. These two parts are the core portion of my program, and to store this source program we use symbolic table, and to represent the header file we use common routine. So the size is 70 plus 80, that is 150, plus 20, that is 170, plus 30, 200. So our required memory space is 200 KB, whereas our available memory space is 150 KB. So to deal with such a problem, we first divide or create two overlays. Overlay A, it consists of first pass 1, common routine, and symbolic table. This symbolic table is used to store the source file representation. A source program is represented through symbolic address, and the necessary header information is represented by using this common routine. So what is the size of this? This three part is encapsulated, and we generate overlay A, and the size of the overlay A is 120 KB. Next we similarly design overlay B, where pass 2, common routine, symbolic table, and the size of the overlay B is 130 KB. Next, our next objective, like say if this portion is our main memory, which consists of common routine, or which is actually header file, or the in case of object oriented we import the different packages, and symbolic table is actually represents the source address space, and there is another driver is present, that is called overlay driver. Overlay driver actually it is mainly used for context switching purpose. Context switching was switching between two different processes. So at the present time the idea of overlays is to keep in memory only those instruction and data that are needed at any given time. When other instructions are needed, they are loaded into space occupied by previous instruction. This is the actual major concept of overlays. So firstly, overlay driver will fetch or call pass 1, and the execution will start. The main memory size is 150, but presently the size of the actual memory space is pass 1 70, common routine 30, 70 plus 30, that is 100, plus symbolic table 20, 120, plus overlay driver 10, 130. So we can execute this pass 1, then overlay driver switch out or this pass 1, and again request for pass 2 to for its execution. Then pass 2 actually enter into this main memory space, and this now the size is 140 KB, and actual memory space size is 150 KB, which is the, so both this overlay A and overlay B both can accommodate by using this single memory space. So the actual requirement is 200 KB, but the actual physical memory size is 150 KB in that case, and both this concept will be executed properly by using this 2-pass assembler. Similarly, we can create 3-pass or 4-pass by using creating overlay, say to overlay A, B, C, D, E based on the requirement or how the programmer will design his or her code. That is the most important part. So in that way overlays is executed. So I think you are quite understand what are the concept of overlays. If you have any doubt, then you can mail me or comment in this video lecture. Thank you.